Hello, welcome to the second event in the first Critical Climate Week at Ontario Tech University. Today we're lucky to have Nicholas Carter with us. Nicholas is the co-creator of plantbaseddata.org and director of environmental science at the Game Changers Institute. Since its inception in 2019, the Game Changers, a documentary promoting plant-forward nutrition, has been viewed by an estimated 75 million people in over 190 countries. Carter's research focuses on sustainable plant-based farming, the impact of animal farming on global greenhouse gas emissions, and disinformation about animal agriculture. This online lecture is sponsored by the Faculty of Social Science and Humanities. I'm Peter Stute, I'm the Dean of the Faculty, and the Office of Campus Infrastructure and Sustainability at Ontario Tech University in collaboration with the Canadian NGO Common Earth. The presentation, entitled Methane, Meat and Misinformation, Food's Methane Challenge, Viable Solutions, and the Myths Delaying Action, will focus on methane emissions from the animal agriculture industry, examining the proposed solutions alongside broader mitigation opportunities and strategies. It will also dissect the myths and misinformation used to delay critically environmental accountability, including new approaches aimed at altering how methane is measured within the meat and dairy sectors. Thank you for joining us, and I hope you enjoy this presentation.
Great. Thanks so much for having me. I'm thrilled that there's a Methane Awareness Week. Honored to be invited. So my presentation, as Peter mentioned, is specifically on methane from the animal agriculture industry. And I'll highlight kind of the broad picture. Then I'll kind of go through some current mitigation strategies. And I'll discuss kind of many of the myths that I would consider to be delaying change. One of them is included, one of them that I'll discuss is a new greenhouse gas metric called GWP star. And this is a new approach aimed at altering how methane is measured, specifically within the meat and dairy sectors. And the link to my report on this, including hundreds of references, can be found at the QR code that you could scan with your phone, and I'll have at the end of the presentation too, if ever you want to dive in a little deeper. So these are some of the groups that I've worked with in some capacity. My time these days is split between the two projects. Peter mentioned plantbaseddata.org, where we gather the best kind of peer-reviewed scientific evidence and do our best to summarize it in various formats, writing, podcasts, and so on. And then, as the director of environmental science with the Game Changers Institute, working on the eco-focused sequel. And I've given lectures, ones like this one as well, at Harvard and Yale before, just this past year. And, I would consider my work split up between two main things. Like what would I consider kind of the solutions and ways in which I think we should shift to, but also, what does the science show and what are kind of disinformation campaigns preventing some of these main solutions. And I always like to mention these presentations as well. To declare that I don't have any financial or industry conflicts of interest. And I do my best to mitigate to my personal bias by citing the best available scientific evidence that I can find. So broadly, methane is a greenhouse gas. It's about 30 times stronger than carbon dioxide over a 100-year time frame, or about 80 times more potent over 20 years. And importantly, it's going up. There are also key differences to know about methane versus CO2, which I'll get into a few times in the presentation. Methane lasts in the atmosphere, causing most of this warming for a decade or two, while CO2 lasts hundreds of years, accumulating significantly over time. Now, because methane is short-lived, rising, and extremely potent at trapping heat, it's also considered like our emergency brake for the climate crisis. Cutting these emissions now is crucial to avoid tipping points like ice sheet collapses and permafrost thaw. In the next 20 years are especially important for achieving climate goals, not just to avoid these critical tipping points at risk, but also during this time, methane emissions are predicted to warm the planet almost as much as CO2. They're very, very close. So it should be getting just as much attention. But we're not doing well with methane. Concentrations are still about 262% above pre-industrial levels. And a 2024 study just came out a few weeks ago, actually, showed that the growth rate of the atmospheric abundance of methane reached about a record high of 15.4 parts per billion between 20 and 2022. And interestingly, the biggest increase between 20 and 2022 came from biogenic sources, agriculture, landfills, but also some natural sources like wetlands. And we can tell this from like the isotopic signature in the atmosphere. So I can share a bit more about that later. Specifically this presentation, many don't realize that food is the biggest share of human-caused methane at about 40%, with about 32% of that coming from animal agriculture, mostly belches, burps from ruminants like cattle, but also mass amounts of manure. Before I go to the next slide too, I'll also just mention like this isn't like an either or thing either. There's huge opportunities in capping methane leaks from fossil gas, natural gas, whatever you want to call it. It's not an either or thing, but my work is specifically to food systems. So that's what I'm focusing on. The United Nations Methane Assessment Report of last year said cutting methane is the fastest and most effective way to slow global warming. Now, as shown on the left of the screen, methane, second from the left, has contributed about 0.5 of the 1.1 degrees Celsius of warming to date, based on when this report came out. Might be a couple degrees more on both those now. So that's second only to CO2 that's caused 0.75 degrees of warming. Now, factoring in the temporary cooling that accompanies CO2 with sulfur dioxide, some have shown that methane has caused up to about 45% of warming to date. But keep in mind, most estimates put it at about closer to about 30%. The main issue here for food is the 4 billion farmed ruminants, mostly cattle. And to put these numbers in perspective, if cattle were to form their own country, they would rank third behind China and the United States among the world's largest greenhouse gas emitters. And across the US specifically, cows emit more than 2 times as much methane from belching and manure as the country's oil and gas wells. And, we know this. And then, I'll share a few different ways in which we're measuring this. But I just want to point out just a couple of weeks ago, on the world's largest podcast and platform, Elon Musk was on there saying that methane from cows, and I quote, is not going to make any difference to global warming. And if people eat pure steaks, we're not even going to be able to measure it. Now, this is categorically false. We are measuring it through infrared cameras, satellites, air samples, long-term monitoring centers, et cetera. And it's showing that the major increases are actually coming from sources like cattle and landfills, even more so than fossil origin. And we can tell this by its isotopic structure. We can see here, ruminant livestock numbers are going up, but also per capita meat production is also going up. Countries like US and Canada, we've had this high kind of per capita consumption of meat for decades, and we may be starting to reduce a bit. But the thing about what we're doing right now is we're exporting that kind of Western diet globally. And there's strategic efforts, industry efforts, which I can mention a few things, to bring kind of this factory farm model that we're so used to seeing in the US and Canada to poor countries or medium income countries across the world. And oftentimes this is displacing otherwise nutrient dense, culturally appropriate plant foods that should be abundantly available for anyone. And while there are efforts underway to increase efficiency of beef production in Western countries like Canada and in the US, these are minor methane mitigation results and usually involve more intensive factory farming that brings a host of trade-offs. So it's important to, before getting into some of the myths, to first kind of acknowledge that tripled meat consumption in just over a century didn't just happen because of free will. It's a systemic result of subsidies, lobbying, marketing, funded academics, and governments bailing out conglomerates like Tyson, Cargill, JBS, and Fonterra. Some of the biggest companies in the world are livestock companies, and they're often given a pass on any form of emission or environmental damage reductions. This is despite the top 5 meat and dairy companies emit more greenhouse gases than ExxonMobil, Shell, or BP. And most of the top 35 global meat and dairy giants either do not report or underreport their emissions. And most of what they are attempting to do is to gain a social license and create these kind of sketchy carbon neutral claims, which I can chat about a little bit. And or they're saying they're doing as much as they can on the energy side, but with food, what we see the biggest issues is the methane and the land use and deforestation. That's where you're really going to get the biggest impacts environmentally. So we should be wary. We should be very wary of these kind of major polluting companies pushing net zero or climate neutral claims. Despite committing to be net zero by 2040, JBS, the world's largest meat company, increased its annual greenhouse gases by 51% between 2016 and 2021. And I authored a detailed report that covered some of this that came out earlier this year via the Freedom Food Alliance, outlining dozens of disinformation strategies and solutions. And on the top right, you'll also find a report by Changing Markets called The New Merchants of Doubt, where I was one of dozens of authors who contributed. But so what myths can maintain a growing animal agriculture industry? I think that's what's really important to understand here. And let me cover a couple here, but keep in mind many of these it's important to also personally acknowledge that I thoroughly bought into some of these as well before I really dove into the topic, which would have started in my graduate studies. Better beef, that's one of the biggest ones. Of course, methane, we know most of it is coming from cattle. But what if you can just graze cattle better? The industry is incredible at telling crafty stories here. These kind of happy bucolic narratives of lush pastures and biodiverse areas that cattle graze. The problem is it's mostly BS. Firstly, grass-finished beef is the worst performing single food that people consume, and it's contrary to initial perceptions. You think local grass-fed beef. Oftentimes, people think of that being an eco-friendly thing. But the fact that it's local, the transportation of beef makes up about 1% of its total climate footprint. What matters more is the land use and emissions relative to other food choices you have. Some scenarios like this were mapped out if we shifted to grass-finished beef from feedlot beef. And we'd be producing about 4 times more methane, give or take. And the reason that is 2 main things. The biggest one is that it takes the cow longer to get to a slaughter weight. So they're out there emitting methane for a longer period of time. But also it's more of a fibrous diet. So they're getting more burps and more methane coming out from that. In a study in the US with researchers from Harvard and Boston University showed that if Americans shifted to grass-finished beef, they'd only meet 27% of current beef demand. And wrapped up in this whole message is, regenerative agriculture and the topic of that. And let me just first say, there is many improvements and opportunities to regenerate agriculture, whatever you want to call it, restore it. And there's also ways of doing plant agriculture better too. Let me just be clear about that as well. But you might have heard this term, and certainly the funding going into it is largely corporate investments in the grazing aspect, and that's certainly what's centralized in it. Usually regenerative agriculture also includes cover crops and using more compost and avoiding monocrops. I support all of those things. Lots of good science backs that up. But the grazing part of so-called regenerative ranching would use about 2.5 times more land than even typical grass-finished beef. So we always got to keep that in mind of what are the trade-offs when we look at these different things. So we'd be taking a practice, ranching and beef production, that uses more land than any single human use of land right now, which is about 1/3 of all ice-free land around the world, and we'd be doubling it. So this is not a solution at all. But just to kind of frame the perspectives that you will hear on this, it's all about soil. We're improving soil health, and if we can improve soil health, then that's great. Keep in mind that the biggest cause of soil degradation globally is overgrazing. So it's ironic that just doing that better is kind of the magical cure. And two, I think this is a more important point, is there's no study that shows the benefits of better grazing that compare to wild native ecosystems nearby. And it's these wild native ecosystems that we need to free up. And certainly the solution of shifting more or all plant-based is a massive solution, because you free up so much land. These hypothetical scenarios, not saying that this would be easy to do, but the hypothetical scenarios where we shift to a plant-based diet globally, we'd be freeing up 75% of agricultural land. And there's lots of modeling studies that show the benefit that would be to not only biodiversity and animals, but also carbon drawdown. So there's lots more to cover on that topic there, but I will just point out the bottom there showing that McDonald's is pushing this in a big way. And there's also a key person that's just been appointed to the upcoming Trump administration, Joel Salatin, who is one of the most famous regenerative ranchers. So you'll be seeing a lot more of this. So yes, I think it's important to also understand that there are wild ruminants who emit methane too. And this is also, I like to show this because this is kind of like pre-bunking. If you have not seen this claim, I suspect you probably will on and on into the future for at least several more years. Wild ruminants who emit methane, like bison, deer, and giraffes even. But the benefits of these animals in like a functioning predator-prey relationship, it's far higher than the emissions that they emit. Cattle don't just perfectly replace wild bison. Now let's look at some of the numbers on this. Globally, over 4 billion farm ruminants release about 130 million tons of CH4 per year, about 60 times more than wild ruminants. And even at the peak of the last ice age, with huge herds of wild ruminants like bison, deer, and antelope, they only emitted about 16 million tons, so about 11% of the current farmed ruminant methane emissions. And often you hear these claims in North America where, cattle graze today. But there are more cattle today than there were bison, and they're bred, raised, and slaughtered in an industrial production system, which can feed animals as much as 4 times per day. And during that time, they're emitting more methane as a result. And globally, livestock numbers today are much higher than native ruminants. So naturally, livestock emissions are much, much higher than before. And we can see those emissions in their isotopic fingerprint in the atmosphere. Now, you may have also seen, there's been lots and lots of media coverage over the last several years that seaweed can play a role here. And, I see these studies and I see these this media coverage, and, I'm curious. I dig into it. I ask questions to the researchers and also colleagues, because maybe there is something that might come up that can be a solution that doesn't need to be, drastic industrial changes from that food production system. So and looking a lot more into this kind of red seaweed claim, it's a red algae from tropical oceans that has shown to have some kind of anti-methanogenic properties. Countless headlines have shown this. Some have even claimed that they can reduce methane by about 80%. So perhaps instead of kind of making, drastic changes to go plant-based, we could just feed cow algae and get on with it, or so the thinking goes. Unfortunately, just kind of looking at these numbers, there's a few issues with it that, I can easily just point out here. We would need a scale to about almost 2 billion cows worldwide, including 100 million in the US. And that mass growing of this particular, warm ocean red seaweed would have consequences. But the only applicable area where cattle would be consuming this would be in the feedlot. So they, have most of their lives on pasture, and then they're finished on a feedlot in most systems. But that's where it's needed. In these crowded final few months of their lives, they'd be given this seaweed. And if you look at how much methane cows emit over their lifespan, over their entire lives, only 11% of their lifetime output comes from the feedlot. So when looking at like even the most optimistic claims of, say, an 80% reduction in methane, we need to look at just that 11%, right? Just that amount on feedlot where it's useful. There's also lots of research that shows a few different things. That one, cows don't necessarily even like it, so you need to kind of fit it in inconspicuously. There's also a lot of research showing that no matter what you feed cows, their guts will adjust and react, just like our guts will adjust and react to different things that you'll eat. And even if that were to be the case, you'd be looking at about an 8% in the best case scenario drop in methane. So worth pursuing, but certainly not to capture the media attention that it's captured, and to make people feel good about the most polluting foods that we might be eating. There's even a new study that looked at this for Wagyu beef, and we would see about a yield of about a 3% reduction total, even in the best case scenario. I think we'll probably move a bit beyond the seaweed claim and look into more kind of pharmaceutical feed additives. Like there's one called 3-NOP by Pfizer, which is called 3-NOP Bovaer. It's the same idea. There shows to be some slight benefit, but it comes with trade-offs. I think worth pursuing to some extent, but to keep it in perspective. It's also generally clear that when you're showing these studies and getting the media attention, we also want to compare to what are the best solutions we have right now for reducing methane, and all of them will pale in comparison to just reducing herd sizes, producing far less, and working on helping people consume far less, whether that's alternatives, whether that's more availability of plant foods, whole plant foods. There's many different options. Now, ironically, the same industry funded UC Davis Clear Center, advocating to reduce methane through feed additives, is also pushing the nonsense that methane and CO2 from cows just perfectly cycles, and that's not a problem. So, which is it? Is it a problem or is it not? This narrative conveniently ignores the warming effects of methane emissions by only focusing on the CO2. Photosynthesis takes CO2 from the atmosphere while cows emit CH4. So this is far from climate neutral, as CH4 has, much larger warming effect while it persists in the atmosphere. And the fact that the carbon atoms in methane come from the atmosphere initially, from say like the grass that was consumed by cattle, is virtually irrelevant to the total warming impacts. And the IPCC AR6 report from last year made this very clear, and I quote, "Increasing numbers of livestock is directly linked with increasing CH4 emissions. Continued global livestock population growth between 1990 and 2019, including increases of 18% in cattle and buffalo numbers and 30% in sheep and goat numbers, corresponds with CH4 emission trends." So if you were to kind of Google and look up right now methane and flow gas, or just to understand a bit more of how methane works, one of the first top entries you'll get is this UC funded Clear Center, UC Davis Clear Center. And it's an industry funded center, highly industry funded, which you can easily as well find. But you'll see this blog talking about how methane is a flow gas, and it's around these same kind of narratives that it just perfectly comes and goes. Flow gas, there's some truth to it. That's how the best kind of like manipulation here is like a half truth. But it's typically referred to substances that are emitted and removed from the atmosphere very, very quickly. That's having a more kind of transient impact. But methane still lasts in the atmosphere for at least 12 years. And, some of the traces of it still last about 40 years. And most importantly, there's still a significant stock and it's still going up. So accepting current levels as the current baseline, and I can't really stress that point enough. That baseline of the current methane emissions, it's not going to do it. We need to reduce them, and we need far less. These are just some of the IPCC calculations showing there's virtually no difference from fossil versus non-fossil methane. It doesn't matter. The atmosphere doesn't see the difference and decide whether to warm or not. We can tell some of the differences of where methane is coming from in the atmosphere from some of its signatures it has, but it's going to cause warming regardless. And there's also lots more to understand about methane. There's some natural impacts of methane from, say, wetlands, which, the ecosystem benefits of having wetlands, I believe, far outweigh some of the methane that they emit. But we should still try to understand a lot more of the natural emissions of methane as well. Now, there's a lot going on in this infographic, but you can find that in my report. But I think this captures a bit more of the complex travels of methane from cows. This baseline claim of keeping emissions steady to supposedly kind of be warming neutral, or even maybe slightly reducing methane to then be cooling the planet. This is where this new metric called GWP star comes in. And I'm going to describe this in a few different ways. So if you don't get it right away, I think you'll get it after a few different ways of me explaining it and then sharing the implications of it. And there's a few more methane myths out there, but I'll focus most of the rest of the presentation on GWP star and how we're kind of measuring methane through this, this metric. So GWP star is it's a new tactic model that features changes in warming of methane over time, accepts a high baseline, and as a result rewards the biggest current emitters as if we were all starting at ground zero. GWP star was first introduced at COP24 in 2018, and it attracted support way beyond its creators, which mostly involved the academics Miles Allen, Michelle Kane, and a few others. But the interest in it now is almost exclusively from those affiliated with beef and dairy industries, or countries where agriculture comprise the highest share of emissions, like, say, New Zealand or Ireland. As we showed in our Seeing Stars report with changing markets, depending on the choice of baseline year you choose, like dude in the flag there in my slide here, the same volume of emissions can be described as causing warming, no warming, or even cooling. So this has meant that it can be used by major methane emitters to justify continuing business as usual, resulting in lack of action to cut methane emissions and disproportionate accountability to those who have emitted the most and caused the most environmental issues. And I promise this is the most very technical diagram I'll show, and then I'll talk about the implications. But I think it's important to show this to share of kind of some of the findings that we found from the report. So stay with me here. I think it's essential for kind of understanding the implications on the next few slides. So on the vertical axis here, you'll see methane emissions measured by different CO2e equivalents. So it's CO2e. Metrics such as, and you'll see many different equivalent metrics to kind of try to capture all emissions into a CO2e, and I think that's kind of an important. I'll describe a little bit of why that is, but you'll see metrics like GWP 20 or GWP 100. That's the most common. That's the one that the Paris climate agreements were based out of, and what most national climate agreements are based out of is this GWP 100. But then you'll see this new GWP star. And from a metric, what we want is both that it tracks GSAT, which stands for Global Mean Air Surface Temperature, but also annual emissions, and more so not allowing the biggest emitters to just get off with a slight reduction and kind of accept that they're cooling the planet. We don't want one that looks at changes over time, but one that considers historic and baseline high levels of emissions as well. So the GWP star metric, as shown here, was designed to match temperature change, GSAT, but focuses on changes over time rather than the absolute total warming levels. By using current elevated methane emissions as a baseline, GWP STAR allows high emitters like the animal agriculture sector to downplay their contributions to methane and to warming in general, even appearing to be climate neutral despite substantial continued methane outputs. So since methane decays with a mean lifetime of about 12 years, and is particularly powerful in that time, we found in that report that there's no justification for accumulating it from 1750 as GWP STAR proponents do to make it appear favorable. These GWP proponents, GWP STAR proponents, calculated it using this pre-industrial 1750 starting point, where initial emissions were close to zero, and using a more recent baseline, which is what we did to correct some of this. They didn't do, but it would be much more helpful to show how methane actually happens in the atmosphere and happens from emitters. So this approach would make it harder for industries to claim that their emissions are neutral or cooling, just because they've flattened or recently slightly reduced in recent years. Now, what we did show is that GWP 20 can equally match GSAT if used correctly, and it's shown in teal in the diagram there. With a recent 40-year timeline is what we chose, and we chose that timeline because that's where more than 95% of emitted CH4 is degraded. Now, calculating this GWP 20 over 20 to 40 years accurately captures the warming impact. Unlike GWP STAR, it does not let off the highest emitters to kind of want credit for some sort of cooling. Now, in our report, we advocated for this 20-year timeline to measure methane, since our issue is urgent and we should be looking at these next couple decades. We don't have 100 years, but if you were to measure this over 100 years, GWP 100 would look pretty good, if not maybe a little bit underestimated. But all to say, the science is far from settled on GWP STAR being a useful addition to greenhouse gas accounting. And the main issue lies in how it is being used by the biggest polluters to try to pretend like they're doing their part and acting like this is a comprehensive picture of methane's current impact. And again, with this slide, the past emissions and current baseload of methane emissions is what GWP STAR ignores. And if I could put it like in a different way, claiming progress with GWP STAR for slight methane emission reductions is like celebrating that you're slowing down after speeding on the highway, but you're still well above the speed limit. It gives the false sense of achievement while the risk remains high. And while the use is currently with animal agriculture, it's equivalent to an American fossil fuel giant saying they're cooling the planet now because they went from 100 fossil gas fracking sites to 90, and putting the blame on maybe like a small under-resourced country for just adding 2. So, understanding how this happens in the real world, and even with a technical thing like that, how it's already kind of starting to be weaponized with different national greenhouse gas accounting schemes is really important. So under GWP STAR, a few major feedlots emitting, say, 10 million metric tons of CO2 a year, that doesn't change their herd, could claim to be climate neutral under GWP STAR, even though they still emit the same amount each year. And say they got a feed supplement, or they're able to slaughter the cows a little bit earlier and they emit 8 million metric tons the next year, then they can be claiming to be cooling the planet under GWP STAR, even though they still emit a huge amount, and methane globally is still rising. And lastly, here's the big kind of inequity implications of GWP STAR. Say there's a poor country who got a few cows to meet basic food security in the short term. They would be penalized as contributing to global warming under GWP STAR. Now, under GWP 100, Tyson's emissions with 30% reductions in 2030 would still emit about 58.5 million metric tons of CO2e, which is relatively accurate. And, it's similar to Peru's annual emissions total. But with GWP STAR, Tyson could be claiming negative emissions and cooling the planet, And wherever Tyson is headquartered, that country could also just start ramping up fossil fuels because they're accepting this sort of credit in this kind of sketchy way. For Fonterra, this is going to have big implications in the next couple of years because New Zealand's probably the first to actually adopt this GWP star in their practices. They're the largest dairy exporter, Fonterra, and a 30% reduction between 2020 and 2030, calculated with GWP star, would enable the company to claim to be taking about 19 million tons of CO2 equivalent from the atmosphere, while according to GWP 100, they'd still be responsible for about 21.6 million tons of CO2e. So we calculate a similar trend for New Zealand, where half of all emissions come from agriculture, mostly methane. With a modest 10% reduction in methane emissions, the country could report negative emissions using GWP star by 2038. Falsely accounting this as cooling would allow less accountability for other sectors. The GWP star proponents have put this forward as like a benefit, which makes no sense to me, because we want to reduce emissions from all of the big industries, not just reduce one and allow another to pick up. So New Zealand farms about 6 million cows and is the world's biggest exporter of dairy products. At least 44% of all New Zealand's emissions come from animal agriculture. So it's no surprise that GWP star advocates have a receptive audience in this country, and the industry academic behind the UC Davis Clear Center pushing a lot of this nonsense about methane. Visited New Zealand on a trip paid by Beef and Lamb New Zealand to promote GWP star and how managing methane from livestock can be a climate solution. So using GWP star, the U.S. beef and dairy industry could claim to be climate neutral while still emitting 68 to 82% of its current emissions of methane, and 100% of the carbon dioxide from deforestation, and 100% of its nitrous oxide from fertilizers and manure. So this shows just a bit of a breakdown of the negative and positives of what happens when you kind of mess with some of the greenhouse gas accounting. And last couple of slides here. So this peer-reviewed work at the top right followed my report on methane, and we contributed with these authors on a webinar covering the topic too, which you can see on the QR code there, if interested to watch that. And the scientists here talk more broadly about the sketchy climate neutral claims we're seeing, but a lot of it does have to do with methane. And I just want to point out in 2022 that the National Cattlemen's Beef Association called for a GWP star to become the global standard. And it's backed by Cargill, Tyson, McDonald's, and they're lobbying in a big way. They're probably lobbying right now at COP29 about this. And just to conclude, last couple things, I know we're at time, but I'll just wrap it up by just saying, overall, methane is going up. We know how to reduce it. And I think we should all make sure that we don't fall for industry attempts to kind of fiddle at the margins or manipulate accounting like that there. And know that there's a risk of falling into this kind of climate tunnel vision too. We, of course, also need to look at Earth systems overall and see that there's pressures from all angles. And, methane is a big part of my work, but also land use, I would say, is also a very, very important metric worth diving into. I'll wrap it up there and welcome any and all questions.
Okay, thank you very much, Nicholas. And really interesting stuff. Not surprising, the effort, I guess, right, to obfuscate and claim credit when for various reasons. Of course, production is going to drop anyways. So it's really interesting. There are some questions that came up in the chat. So rather than take this time up myself, because I do have some, but I'll refer to the chat questions, I think, first. And I did want to thank also our sponsors. There's an NGO named Common Earth in Canada, which is doing some great stuff.
Good stuff.
And agriculture is, really related to their work. So thanks very much to Common Earth. and also the Campus Infrastructure and Sustainability Office at Ontario Tech University. So there was a question about cultural customs and meat and religious practices, and aren't you being a cultural imperialist here, telling other people not to use meat this way?
Yeah, I think when we focus our work on methane mitigation, I think the effort should be on those who have emitted the most. And I think that's the same for any environmental metric as well. Those who have caused the most damage, which a lot of the time are people that look like me in rich countries like Canada and US. They're responsible to do the most to reduce. And at the same time, I think the topic of food brings an extra level of complexity on this too. None of this should be focused on these under-resourced countries. What's interesting is GWP Star has major inequities. Maybe a country like Uganda having smallholder cattle, and we're talking maybe 5 to 12 cattle at a lot of small families. There is a big push for factory farming there, which I think we should block. But they would be penalized under GWP Star as contributing to warming, and they might add a couple each year, a couple every couple of years, and I think that's a big issue. I think just overall too, there's many culturally appropriate plant foods that we should abundantly make accessible, regardless of what people choose. And we should be calling out kind of industrial marketing attempts to dictate what we eat, because that's largely what's been happening for many, many decades. And that's kind of why we have a food system we have now.
Yeah, well answered. The distinction between feedlot and grazing, someone picked up on that a bit, and clearly feedlot is more pernicious and dangerous, right, in terms of the environment. But is the to emphasize grazing instead leads us down that path of, well, we're just replacing the bison, basically. That's how I tend to take it. But could you comment on that directly, maybe, feedlot versus grazing in relation to methane?
Yeah, I mean, in North America, we have feedlots of 80,000, 100,000 cows, and if you don't know what that looks like, just Google it, take a look. It's a horrible picture, but that is largely how people get beef. That is where our food comes from. Now, the idea of grazing, I mean, it's a whole presentation could be done on grazing. It's such a complex topic. There is a wide spectrum to the impacts of grazing, but if you look at grass-finished beef, and you look at extensive production systems, they actually have a higher overall footprint than the feedlot model. Now, the feedlot model might have more kind of runoff and might have more, certainly more zoonotic disease risk, and likely more antibiotic use and things like that. So there is trade-offs. But in terms of the amount of land cleared, especially land cleared per amount of beef that you get, but also methane emissions, it's higher in these kind of extensive grass grazing systems, even if they might be finished on a feedlot after, or if you want to go to grass finished beef. So I think just a lot of people, including myself, previously have been tricked by this model. And I think industry is taking advantage of that story. And we're going to continue seeing regenerative beef soon at a McDonald's close by, and even at the grocery store, and it'll rely on these lush pictures of pastures that don't show what was there before: a forest, a wetland, a peatland. That's what we need more of.
Yeah. Martha, you've got your hand up, but we're just taking questions in the chat. So if you could just put your question in the chat, please. I'm happy to read it. There are some requests to go over GWP Star again, how it fudges the numbers, and how it differs from traditional ways of measuring methane's impact. And I don't want to have you repeat too much, but you did mention, I think there are some sources, right, that people could access to get a better sense of this, because as we'll see more and more of it, And interesting, you mentioned COP29 because I think it is being actively discussed, isn't it, as a possible measuring stick? Yeah. So we'll hear more about this. And are there sources that you recommend we look at? Your report, obviously, which I think is this the one we can use
Yeah, you can take your camera on your smartphone there and just put up the QR code, and you'll get the third link down is the Seeing Stars report, which I go through this. We also have an accompanying video that walks through a bit of the science in a way that shows it as best as possible. The tricky thing about this topic is, I mean, greenhouse gas accounting is incredibly complex, and in the best case scenario, which I do mention in the report, we would be able to measure each gas by its kind of radiative forcing, like the impacts it has on an individual basis. The reason why I mean, there's a few reasons, but one reason we went towards like this kind of like carbon dioxide equivalent, like this CO2, this kind of like exchange rate of one figure through GWP 100, like measuring warming over 100 years to kind of get like a standard number. The reason why we did this largely was like because of like the Paris agreements and like these global commitments where there's a diverse amount of things you're feeding into this model to understand each country and ideally companies' contributions to warming. So it is an evolving science that we need to continue to improve. And I don't think any of those metrics are perfect. Even the one that I would advocate, GWP 20, can at times overestimate the impacts of methane if you're looking at it 30, 40 years out into the future. I would just refer to the report that I wrote there, that we put really careful attention to try to word it as best as possible to understand it, but also not miss the complexity and the technical side of it.
Mm-hmm. And you're focused on beef here, obviously, but what about other animal factory farming? Is that,
I mean,
is there a reference to GWP that as well?
Yeah, it would apply to the manure. I mean, there's mass manure lagoons from pig farms, and anyone who lives near a pig farm can attest that the air smells. It's hard to breathe. You get stinging symptoms. There's more asthma rates. There's health concerns, real public health concerns, to be near one. And with chicken, chicken is considered by many as the most kind of eco-friendly animal source food to eat. But it's still about 10 times more emitting than legumes and pulses and beans. So keep that in mind. Like, there's still far better options. And I think the impacts of chicken are a bit less on greenhouse gases and more on the runoff into river systems that you get from producing hundreds of thousands of chickens in a barn and needing to deal with the feces and manure after. But also, probably even bigger than all that would be the pandemic risk, the zoonotic disease risk. And I mean, that's not my exact area of research, but there's many that are working on zoonotic disease risk and will attest that chicken farming, no matter how clean you try to make it, no matter how many standards are in place, like there's a lot in Canada, there's still a high risk of zoonotic disease. And, you can look up bird flu and see that it's still relatively low risk right now, but months go by and years go by and then it's not. It's already shifted to people, and it hasn't shifted much from people to people. But I don't know. I don't want another pandemic. I don't know. Yeah,
and we've got someone with an avian flu in BC right now, right? Apparently. So it's in the Canadian context as well. Okay. Do you think that I ask this question on every chance I get to people like you that are so active in this area, but as individuals, what do you think people should be doing? What if you could wish upon us an act? What would it be?
I think one of the first short-term kind of smart policies that we could put in place would be increasing the abundance of healthy plant-based foods. And that looks like a few different things. There's a group called Default Veg or Better Food Foundation, which works a lot on kind of like, there's another group called Greener by Default. And there's lots of research that shows like, behavioral shifts and how, we're constantly nudged to do certain things, different behaviors, right? And food, 3 times a day, we're nudged to eat a certain way. And there's a lot of good university studies too that look at if the catered system, doubles the amount of plant-based options, you more than double the amount that is chosen. And even when you make it the default, oftentimes the satisfaction does not drop. The eco-friendliness of the overall diet improves. But we've really only started kind of trying that. That's not really an abundant thing. And I think that largely would be accepted in most politics, left and right, around the world, because it's not restricting anything. One of the best examples I would point to of something that, if you look at an area of the world that's doing very well with this, there's still a lot to be seen, but in Denmark, how they're treating agriculture is incredible. This is an area that has more pigs than people, keep in mind. And there's a big meat culture there. But there's a lot of discussion among different perspectives across the political spectrum, across urban and rural. And, veg societies are coordinating with organic food producers, including meat producers. And just last year, they announced the world's first kind of national action plan for plant-based foods. And this includes trainings for chefs, for menus, for introducing education in schools, and just a lot of practical, helpful things to increase it. And they did largely this with biking decades ago. And in Copenhagen, I don't know what the number is now. I think it's maybe half of short distance transportations now from biking, just because they improved the infrastructure. So I think that can be done. Yeah.
Okay. And then we do have a bit of a contrary perspective that's offered in the chat, that in the spirit of trying to reduce climate channeling thinking, okay, there's equal suspicion about the research in the human health impacts of carbohydrate-intense diets. Research voices have been equally shuttered by dominant healthcare industry into the role of carbohydrates in higher inflammatory states in the body. No doubt you're familiar with this argument as well. Did you have a comment on that at all, or? Sorry, go ahead.
Yes, some of this is the complex answer. I'm not a nutritionist, so let me just say this, but I would just point that some of the longest living people in the world, the centenarians, are in blue zones across the world, and they eat mostly plant-based diet. I mean, I'm in a blue zone right now. Not in Canada right now, but in Costa Rica, there's a blue zone. And I think, that even that science is not perfect. There's lots of other things that have led to the longevity of life there. I would say look up sources, look up peer-reviewed sources, look up the body of scientific literature, and I think you'll get a pretty strong case advocating for more plant-based, not exclusively. On the nutrition side, you're probably looking at above 80% plant-based is a very healthy way of eating. When you get to that 100%, I don't think it makes a whole lot of difference from just the health side. I think that's what I would interpret from my little bit of literature review on the nutrition side.
Yeah. Okay. Well, thanks. And obviously, that's a whole discussion. What we're really concerned about this week is climate and how to reduce, mitigate climate change. And I don't think there's any way around it. If you look at the present agricultural system, we need massive change. And I think that's become very clear this week to anyone who's attended our events. But I think you've made a very sophisticated argument for it as well. So thank you very much, and enjoy your time in Costa Rica. Maybe try and visit that blue zone and share some plants, some plant diet.
Yeah. Well, thanks so much for having me. Really appreciate it.
Okay. Thank you very much. And thanks to everyone that was here. We will, this was recorded, and we'll make it available too. And those that registered but weren't able to attend, we'll get a copy as well. So Wonderful. Thanks very much, Nicholas.
Great. Thank you. See you, everyone.